Hello, mini math lessons with Karen, and today we're continuing our statistical journey, and we are going to be doing an activity, or just overviewing an activity on exponential regression and kind of helping students fit their data with a good mathematical model. And so again, I'm using Classpad.net. If you don't need an account, but if you want one, this is the landing page. Create an account here. That way you can save any work you do on these activities that I'm sharing, or you can create your own, obviously, or you can save them and modify them. So lots of things you can do if you have an account, and the accounts are free. So I've included the link to this activity below in the video's description. So here is the activity, and this is one that's adapted. I just took pieces of an activity from Fostering Statistical Thinking, which is a Casio workbook for their handheld calculators, but we can do a lot of the activities right here in Classpad. In fact, probably more. So this is about Facebook, and the beginning of the activity only provides beginning information. So these numbers represent the years, so 2004 to 2009, and the growth in users in millions throughout those years. And so if you just look at the table, you can see that it grew pretty quickly over these first, 5-6 years. And so students are going to explore this growth and try to fit a model to that with regression. So the first thing that they're going to do, and I've already done it, this graph won't be there when they actually are doing the activity. The first thing they're going to do is create the scatter plot, which is really easy to do. You just select the columns, and then we have this graph menu. And for those of you who are my statistic users, you'll notice there's a lot of statistical functionality here. We're not going to explore it all in this, but just so you know, there's quite a bit if you want to explore that on your own. But when you hit graph, the first thing they're doing is a scatter plot. So we already have the scatter plot. They're doing it on their own. So the first thing is, what do you notice about the data? Does it look like it's linear? What kind of relationship does it look like? And so by this time, students should have an understanding, have been exposed to linear models, quadratic models, exponential models, the cubics, all those different types of models. So hopefully when they're looking at this data, they're thinking, oh, well, maybe that's a quadratic, or maybe that's an exponential. One of those. It's definitely not linear, right? It doesn't look like it has a constant rate, the relationship between the year and the number of users at that year. So the questions over here say, okay, based on what model might be appropriate, so in their answers, which are they going to be put over here, they're going to come up with some thoughts about what model they think would work, what ones wouldn't work, and then they're going to actually test out their model. So that's another nice thing here. They're going to be able to go back here, and you'll notice here's all these different regressions, and they're going to choose one that they think maybe fits, right? So we've already kind of decided, well, it doesn't look like a constant rate of change, so maybe it's a quadratic. So let's just see what a quadratic model looks like. And so here's the quadratic model. Not awesome. So maybe it's a cubic model, right? So let's try that. And clearly that's not it, because this indicates that things are going down. So we don't like the cubic. And if they decide, oh, I don't like that, they can go and quickly trash them. So quadratic's not working so awesome for me, so maybe they'll leave that out. So maybe not. Let's try a different one. So basically they're going to test them out and kind of make some decisions of which model they think's working the best. And then once they think they have a model that fits, they're going to talk about why it fits and what are they, then use this model to make some predictions, right? And so that's where we're going with this. So make some predictions. So if this is their model, they could then graph the function that matches that model, right? And from the function, once they have the function, they'll be able to get a table and maybe make some predictions. So that's where we're going in this first part of the activity. Then once they do this, so that if you notice, they're going to have to, down here, use their model to make predictions about when will Facebook users reach 5,000, right? Or 500 million users, and they're going to put in a year, and they're going to explain where they got that from, and then they're going to predict, what will it be in 2025 based on the model that they chose, whatever it might be. And so once they've done that, they've learned to fit a model. They're looking at how a model can help them make predictions, and then we go down and we provide them with a lot more information. So here's the same six data points that we'd already given them, but now we're filling into the year 2019, and now we're gonna do another scatter plot and talk about why is their model that they did up above, why didn't it work, predictions, all that kind of stuff. Because as you notice, I'll just do this real quick. When I do the scatter plot here, I no longer have it's not an exponential model. It's exponential up to here, and then it almost looks linear up to here. So then it's talking about how one model may not necessarily work for your data, and so then we talk about maybe some piecewise. So all of this is where we're going is, your one model, this model up here, because you had incomplete data, you only had data for 6 data points, and so your model fits those 6, but it didn't take into account that things leveled off and went more linear as the years progressed. So this is the exploration they're doing in these activities. So they're going to actually be creating these plots themselves and their functions and all that to analyze things. So have fun with that.